So today's lesson is on perfect square roots. This lesson does have a little bit of review in it from some stuff that you probably learned in 4th or 5th grade on exponents. And we're going to review that and connect it to what you already know, because this lesson should be very simple, especially if you already understand what it means to square a number. So let's first start with some review. When you see squared numbers, they're written with a base and then an exponent of 2. So this is a base of 4, and this is an exponent of 2. And so what this means is 4 squared, it's 4 times 4. It means that we are multiplying the number that is the base twice. It is not 4 times 2. It's the base being multiplied as the same factor 2 times. So it's 4 times 4, not 4 times 2. And it constantly surprises me that I get kids in middle school that are still doing their exponents by doing their base times the exponent and doing 4 times 2, which is wrong, instead of 4 times 4. So when we say squared, and we used the word squared as a vocabulary word in math, it's actually talking about using the exponent 2. So we don't say 4 to the power of 2. We use the vocabulary word squared. So this is read 4 squared, which is 4 times 4, which equals 16. So this is read 4 squared equals 16. Again, this is a review, so we're not going to put any of this in our notes. If this is something that you do not know already, you might want to go onto Canvas and take some time at home to copy this into your notes so that it will be available to use on your CFAs and quizzes. But we are not going to take time right now. We're just refreshing it and making sure that it's fresh in our memory so that when we look at square roots, we can connect it to what we already know about a squared number. So again, when we are squaring a number, let's look at this picture. How does the term squared come about? So we are looking at a square. We know the length and the width of the square is the same. And so what we're really doing is we're multiplying the length and the width 3 times 3 to find the area of this square. So this is where the term squared comes from. 3 squared is finding the area of a square that has the length and width of 3. So it has the area of 9 squared units. So 3 squared is 9. 3 squared equals 9. So to square a number, you just multiply the base by itself. So here the base is 3. You're multiplying it by itself, 3 times 3, so 3 squared is 9. Easy, easy, easy. This is all stuff we should know already. Just a reminder, it does get a little bit complicated, and this is important because we're going to connect this also to negatives with square roots, which are also a little bit complicated. So when you are squaring a negative number, you are multiplying a negative times a negative. So negative 5 squared is actually the same as just 5 squared. And the reason for that is negative 5 is negative 5 times negative 5. And we know that a negative times a negative is a positive. So that's positive 25. Well, the answer to 5 times 5, or 5 squared, is also 25. So negative 5 squared is the same as 5 squared. The answers are both 25. And that's important because the square roots are also the same. So that's important to keep in mind. So when we square a negative number, we get a positive result. It's just the same as squaring a positive number. So here's what we just looked at. 5 times 5 is 25. Negative 5 times negative is 5 is 25. So you get the same answer whether it's negative or positive. Again, this will make more sense why this is so important when we talk about it in terms of square roots. So a square root is actually the inverse or the opposite of a square. So if I have 3 squared, that's going to give me 9. So then the square root is what you do to 9 to go back to 3. So the square root of 9 is 3. When we are talking about squares, we use the exponent 2. So this is 3 squared, and this equals 9. When we are finding square roots, we use a radical sign. So this is the square root of 9, which equals 3. So here we started with 3 and ended with 9. Here we started with 9 and we ended with 3. So it just kind of shows that they are inverses of each other, and this is the words to match that. 3 squared is 9, so the square root of 9 is 3. A square root of 9 is 3 because when 3 is multiplied by itself, we get 9. So this is the understanding that they are inverses of each other. And we know that also you have multiplying and dividing, those are inverses of each other. Adding and subtracting, those are inverses of each other. So these are words that we've heard before. It undoes the previous operation. So if I subtract 3 and then I add 3, it undoes that previous operation. It puts you back at what you started with. If I start with -3, owing $3, and then I add $3, I'm back at 0. So here if I start with 3 squared and get 9, and then I find the square root of 9, I'm back at what I started with, 3. They're inverses of each other. So this is the first slide that I would like for you to add to your notes. So at this time, I would like for the substitute to pause this video, and I want you guys to take a minute and get this copied down into your notes. When everybody has it copied, we'll come back and press play again. All right, so let's keep going and examining square roots. So a perfect square root always has an integer as its square root, either positive or negative, but it always has a whole integer. Remember, when you're talking about integers, it's whole numbers, it's not decimals or fractions. So if you have -1.2, that's not an integer. If you have -1 2/3, that's not an integer. So we're looking at positive numbers, negative numbers, and zeros. Those are always the answer to a perfect square root. If you cannot get one of those answers, it's not a perfect square root. So here are some more examples. You have 4 squared, and again, we're squaring that even though it's not there. So I can write that like this. Maybe it will make a little bit more sense. 4 squared equals 16, and then the square root of 16 equals 4. So you see how those kind of go from here, and then find the square root to go back to 4. 5 squared is 25. So the square root of 25 equals 5. And then here you have 6, kind of add a space. 6 squared is 36, 6 times 6. And the square root of 36 takes us back to 6. So go ahead and take a minute. Again, pause it and add this little table and this definition of a perfect square root to your notes. All right, guys, so this is really important, negatives. Because you always have a positive answer when you are squaring a number. There's no way to square a number and get a negative answer. If you have -5 squared, the answer is going to be positive 25 because you have a negative times a negative. The base is 2 of the same. You're never going to have 1 negative and 1 positive. You're always going to have 2 positives or 2 negatives, so your answer is always positive, which means you cannot find negative square root of 25. You cannot put a negative number inside of your square root sign because you can't find this square root. There's no squared number that will give you the answer of -25. This is impossible. So if you want your integer to be a negative answer, so if I want my answer to be -5, I don't put the negative inside. So if I find the square root of 25, my answer is 5. We know that. So how would I get the integer -5 if I can't put the negative inside? You have to put the negative outside of your radical sign. So here you're going to find this square root first and then add in the -5 after. So the square root of 25 is 5. Add in the negative, it's -5. And then we can square this and go back, and your answer is 25. So really what we're finding is the 25, the only way to get the negative on that is to put it outside of your radical sign. So be really careful, because technically, if I ask you what is the square root of 25, your answer could be -5 or 5. Because if I take -5 and I square it, -5 times -5 gives me 25. If I take 5 and I square it, I get 5. So we use this symbol in math, it's called the plus and minus symbol, to show that it could be both positive and negative numbers. So the square root of 16 could be both positive and -4. Those are both possible answers for the square root of 16. So we're going to do this in a minute. Don't worry about copying this into your notes, but the substitute's going to pause the video, and I want you guys to take a little minute and put a note in your notebooks about how to handle negative numbers and negative radicals, negative square roots, excuse me, and then how to show those answers. So now what you guys are going to do is you are going to take the next 15 minutes or so of class, and you are going to make a list in your notes of all the perfect square roots all the way up to 400. And I know you think this is going to take a long time, but it really won't. And I guarantee you, you will reference this list more times than you can imagine. And hopefully you'll get most of them memorized just because you constantly look at them and constantly use them. So here's what I want you to do. I want you to write at the top of a page. You're going to go to a new page in your notes. And at the top of the page, you're going to write list of perfect squares. And what we're going to do is we're going to start with 1, and we're going to write 1 times 1 equals 1. Square root equals 1. Then you're going to do 2 times 2 equals 4. Square root of 4 equals 2. 3 times 3 equals 9. Square root of 9 equals 3. 4 times 4 equals 16. Square root of 16 equals 4. 5 times 5 equals 25. Square root of 25 equals 5. I don't have lines, and I also don't have as much space as you guys do, but you should have each of these on one line, and you really want to try and keep your square roots lined up all the way down. When you get to 400 underneath of your radical sign, you're done. So you're not doing 400 times 400. You're doing the radical sign of 400. So you're going to try to get all the way down to your list to where you get the square root of 400 equals. And that is when you're going to stop. So you should have a list almost as long as your page. I am not doing it for you. You have the next 10 minutes to 15 minutes, however long it takes most of you to get it done, to do this list in your notes. So you're going to go ahead and pause this video and make your list. And then when everybody's list is done, we're going to come back to the video and we're going to do some guided practice. So go ahead and pause the video now. All right, guys, so we are going to look at some guided practice problems that include square roots. Some of them are very easy and some of them a little bit more complicated. So we've already done this format for the guided practice. These problems don't have numbers next to them, and I do not know why the number 81 is in the middle of my screen, but this is problem number 1, problem number 2, 3, and 4. So I want you guys to try and solve problem number 1. It's pretty easy, but just do it. And then press play and come back and we'll do it together. So on your desk, hopefully you've already solved number 1. So the square root of 81 is 9. 9 times 9 is 81, so the square root of 81 is 9. Assuming that's what most of you put on your desk. If you really understood today's lesson, ideally you would put 9 or -9. Because how do I know that I didn't do 9 times 9 to get 81? So I would love it if I saw this. I would accept 9 at this point as well. But I will tell you, on your upcoming CFAs and tests, there are some questions that say, what are 2 possible outcomes for this square root? And so I don't want those to stump you, because I want you to know that you could have a positive or a negative outcome. So go ahead and pause the video and try number 2. All right, guys, so when we have this one, there are not 2 possible outcomes, because you do have the negative outside of your radical, which clearly tells us that our integer has to be negative. So the square root of 144 is 12, and then we put in the negative afterwards, so this is -12. All right, go ahead and pause the video and try number 3. So number 3 is a little bit more tricky, mainly because we just haven't done anything like this yet. But we do know that, or at least I hope we know, that 5 is not a perfect square root. It's not on our list, and neither is 11, meaning we can't find those square roots and then add. So when you have 2 numbers underneath of your radical sign, you're actually going to solve underneath of the radical sign and then find the square root. So you would actually start by adding 5 plus 11 and getting 16. And we know that 16 is a perfect square root. So again, your answer is 4 or plus or minus 4, because we have no proof that it's not -4. Go ahead and pause the video and try number 4. So on number 4, we have other operations outside of the radical. And just remember that a square root is the inverse of an exponent. So when you are looking at order of operations, you should always do your square root in the same processes as when you would do your exponent. So parentheses, exponents, multiply and divide, add and subtract. So this answer, this square root, would be step 1. I'm assuming most of you and I would have done +5. But if you said the answer to this was -5, you would have gotten a completely different solution. So we'll work it out both ways. So solving the radical first, it would be 3 times 5 plus 4. Remember, when you solve that, there is no symbol in between the 3 and the square root of 25, but we know that that's multiplication whenever there's no symbol there. So then we would multiply. 3 times 5 is 15 plus 4, and our answer would be 19. Now, if you made the square root of 25 -5, the only thing that would change is this would be -15 plus 4, which would make my final answer completely different, and it would be -11. And I would never mark either of those wrong. But I will tell you, in your classwork, when it throws in square roots to a order of operation, let's just go ahead for right now and assume that it is positive unless it specifically puts a negative in front of the radical sign like number 2 did. I do have a few more problems that I want for you guys to try. So our next problem, again, these don't have numbers next to them. So we're going to call this one number 5. This one number 6, and this one number 7. So for the remainder of these problems, I want you to assume that the answer to the square root is positive unless it specifically has a negative sign outside of the radical sign. So let's pause the video and try number 5. So number 5 is very different. And again, I didn't show you any examples prior to this. So if you're stumped, these are your good examples of solving problems that have radicals in them. This is actually the same, and it can be written a little bit differently. We can write it the square root of 16 over the square root of 4. These are equivalent. They are actually the same thing. So when you see a fraction like this underneath of a radical, the numerator and denominator, you can find the square root of both of those numbers. So then this becomes 4 halves, because the square root of 16 is 4 and the square root of 4 is 2, plus 1 half, and I'm going to go ahead and leave that 4 halves because in order to add fractions, you have to have the same denominator. And so we add the numerator and we keep the denominator the same. That's 5 halves. And we are going to change that to a mixed number. 2 goes into 5 2 times. And we have 1 left over. Ooh, I'm squeezing it in over 2. So my answer is 2.5. And again, you would have a completely different answer if you did -4 and -2. So we're going to use positives for the rest of these unless it specifically has a negative outside the radical. So number 5 is fun. Let's go ahead and try number 6. Pause the video and try number 6. So on number 6, we are going to use our order of operations. We're going to solve our parentheses first. So we're going to do the square root of 169, which is 13, minus the square root of 144, which is 12. We're still solving those parentheses. 13 minus 12 is 1. And then notice you have a negative outside that we add in at the end. So our answer is -1. So go ahead and pause the video and try number 7. So we are going to find the square root of 400 first, which is 20 times 3 minus 125. 20 times 3 is 60 minus 125. This is a smaller number minus a bigger number. So you could go ahead and do 125 minus 60 and just know that your final answer is going to be negative because you are taking away the larger number from the smaller number. So our answer is going to be -65. All right, guys, we will continue to practice working problems with perfect square roots tomorrow. And then we are going to look at non-perfect square roots and what do we do if the answer is not a integer and if it is a decimal or a fraction. So you guys are doing really great with this. I hope you're all doing well. If you need to look at these notes, either this video or the notes that were used during this video, it's all on Canvas under the title Perfect Square Roots.